boy, and then I was like, oh, that's not like, I'm like, I know the one boy. That's so funny. Okay, so again, you don't need to clean up your boards. If you did, that's fine, we'll grab them again. I think we'll do boards again in a second. I just want to talk to you guys about we're adding one more rule today. So we'll have two main rules today that we're learning, and then tomorrow we add some more. Exponents have a lot of rules, so and they can get really confusing, so we got to make sure we understand each of them as they come. So the next one's called power to a power. And hopefully you can kind of look at it and see what that means. It's basically we're taking a power and then raising it to another power again, which is kind of crazy and it looks weird. Now, we're not dealing with something like this today. So I'm actually put this one up here because we're not using it, which is kind of strange. So we're not doing problems like this because this one has two terms. So when you see a problem that has two terms, this rule is not applying because this one has two terms. So this rule only applies to one term. The rules we're going to use right here are only if it's one term. So we won't do problems that have addition. Now you see that and then you see this one, and I'll explain that in a second. So most of these are only one term. So we're going to use this as an example to begin with, like we did on the front side. So a to the third, and then it's being raised to the second power. Just like before, I asked you guys what a to the third meant, and that's really a times a times a. But it's being squared, so that means I have to multiply that by itself. So this is really like I'm multiplying a 6 times. So this is really just a to the 6th. So how would I explain someone what to do with those 3 and 2? What did we just do there? Yep. We're just multiplying the exponents in this case. So on the front side, we added the exponents because they were two different bases. Here we're multiplying the exponents. So trying to keep those two separated. So we're going to multiply the exponents. Now what we're going to do is we're going to have to distribute that exponent to all the bases in the parentheses. So I'm going to write that here because I'll show you guys that in a case like this where it's like a fraction. We're going to distribute the exponent So I said distribute exponent to all bases in the parentheses. So this one's kind of a strange one because they're all variables. So this n power is going to go to the top and the bottom. So all the bases would get it. And then I add, or multiply, sorry. And the order I multiply doesn't matter. I can multiply the m in the front or the back, it doesn't matter, but it's going to get multiplied to the exponent there. So we're going to go down to this example 5. I'll come back to that weird one over there in a second. So this example 5, all the bases need to get this 4th power. How many bases are in example 5? Can you tell how many bases there are? How many like big numbers are there? So is 2 a base? It's an exponent, or it's a coefficient, but technically it's a base. So the 4 is going to go on the 2. But it's also going to go to the x and to the y as well. So it's going to go to all the bases. So it has 3 bases here. They all have to get that 4th power. So this is going to become 2 to the 4th. We'll deal with that in a second. X to what power? What's our rule here? We're multiplying, so 3 times 4 is going to be 12. And then also y to the 2 times 4, which is 8. So my third bullet point up here is the coefficient has to get that exponent too. Coefficient gets the exponent too. We're not quite done with this problem quite yet, but we'll finish it here in a second. Let's get it finished already. Okay. Okay. Yeah. So 2 to the 4th power, we can actually do that. So we want to simplify that. 2 to the 4th power, you can either put that in your calculator or you can just multiply 2 times 2 times 2 again times 2, which this is going to be 16. 2 to the 4th power is 16. Now x, I don't know what that is, so I'm just going to leave this. Sorry, that should be an 8 there. Does it look like an 8? Right? So this next one, so example 6 here, this second power needs to go to everything inside of here. So it has to go all the coefficients, but also all the bases with the exponents. So this 2 is going to go to the 5. It's going to go to the x to the 5th. It's also going to go to the y, and then to the bottom as well. So I'm going to simplify that as much as I can. So it'll be x to what power? What's the power going to be on the x? 10, very good. Y to what power? There's like a 1 here, so we're multiplying the exponents. 1 times 2 is just 2. So this becomes a 2 there. And then 6 to the 2nd also has to get that power. And then we're just going to simplify a little bit. I should be able to figure out what 5 to the 2nd and 6 to the 2nd are. 5 to the 2nd is 5 times 5, so that's 25. And then 6 to the 2nd is 36. So I'm going to simplify it and leave it that way if I can here. So example 7, kind of a lot going on here. We have 2 different sets of parentheses with exponents on the outside, but we're also taking this fraction and multiplying or using the exponent. So that one's this is definitely a tougher problem. You're not going to see a ton like this, but I want you guys to be comfortable with it when it does come up. So we'll talk about it here. So this third power has to go to the 1/2. So we'll deal with that in a minute. But this third power also has to go here and here. And then same thing on this one. So they're all getting that third power inside the parentheses. Now this 1/2 to the third power is more complicated maybe than it sounds like, because technically the bottom of the fraction also has to get that 1/3 or that third power. So I'm going to show that. It's going to be 1 to the 3rd over 2 to the 3rd. A to the 2 times 3 is 6. And b to the 6th as well. And then times, I have to multiply that by the next part. Now I'm going to keep the parentheses around the negative, because remember in the warm-up we talked about that negative is a little confusing with our calculator. And then b to the 3rd. So we kind of have a lot to do here, so I'll kind of pause for a second, make sure you guys have it all written out so you guys can think about it a little bit as well. All right, what's 1 to the 3rd power? 1 times 1 times 1 is just, what is that? Just 1. What's 2 to the 3rd? 2 times 2 times 2. 8, very good. 2 times 2 is 4, times 2 again is 8. Okay? That 8 to the 6th doesn't have anything to go with, so I'm just going to leave 8 to the 6th the way it is. That b to the 6th is bugging me because I know I can go with this b to the 3rd. So I want to put those two together. So that's going to be b to the, what's the rule with that now? The 9th. We're adding those exponents. So remember, when we go back to like the front side of the page, we add the exponents because we're multiplying those bases. So this is b to the 9th. And then I have negative 4 to the 3rd power, which we did in our warm-up. If you look back, negative 4 times negative 4 times negative 4 is a negative 64. So we're really close to being done with this problem. The variables are all combined, but then I have this 1/8 and a negative 64. 1/8 times a negative 64 is really like I'm taking a negative 64 and dividing by 8. What do we get? Yeah, it's just going to be a negative 8. So I like to put that coefficient in the front. So that ends up being like what it simplifies to be completely. Okay? All right, we're running a little bit low on time, so I'm going to ask you guys actually clean up whiteboards, just give yourself another quick break, and then we'll look at these last 4 examples together. Okay. So let's finish with these last 4 examples. The next 2 are really similar to what we've been talking about. So I'll help you guys with 4 and then, with 8, and then I'm going to have you guys try to do 9 on, well, actually, let's do 9 together, and I'll have you guys try to do 8 on your own here. So let's look at 9 together. So in number 9, there's this 2nd power and this 3rd power. I'm going to distribute the 2nd power in. So I'm going to distribute that 2nd power in. So it's going to become 4 to the 2nd, m to the 3 times 2 is 6, n to the 2nd again, because the n currently doesn't have an exponent. But the second set of parentheses is a little bit weird. So do you notice that little negative in there? What's that really the same as? A negative 1, very good. So there's like a negative 1 there. So that negative 1 also has to get that 3rd power. It's a little bit strange here. So all of those are getting the 3rd power. So it'll be a negative 1 to the 3rd. Again, anytime it's a negative, I like to put it in parentheses so I don't forget that for my calculator. M to the power to a power, you multiply, so 12. And then n to the 3rd. So take a minute to make sure you're okay with where I got all that from. We're not done yet, but I want to make sure you guys are okay with that first step. So we distributed that power in. Okay, any questions on any of the numbers? And it's possible I made a mistake, so I don't see anything, but let me know. All right, let's deal with the coefficients. So 4 to the 2nd and negative 1 to the 3rd. 4 to the 2nd is what? 4 times 4? This is going to be 16, right? And how about negative 1 to the third power? It's negative 1 times negative 1 times negative 1, which is negative 1. So I want to multiply these together right away, if that's okay. This is technically that. So 16 times a negative 1 is just a negative 16. So I'm just going to put that together that way. All right, now let's look at the m's. How many m's total do I have? Please don't get your calculator out. 18, because we don't need to multiply, and we're adding the exponents, because now we're back to like the front side of the notes there. So it's going to be 18, and then n to the 5th, you just add those. All right, so take a minute to look at number 8. I'm going to give you guys a little clue with number 8. That 4th power is only on the second set of parentheses. So this 4th power is only attached to this one. This one doesn't have a power at all, like attached to it. So take a minute to see if you guys can try number 8 on your own, or if you're totally nervous to try it on your own and you're writing in pen, you want to wait, it's up to you, but I suggest trying. We'll talk about it here in a few minutes. Number 8 here. So hopefully you guys heard my warning that that 4th power is only on that second set of parentheses. So this 4th power is only on this part. So it doesn't go to the first part at all. So this first one just going to stay as it is right now. The second one though is going to get the 2 to the 4th. So 2 is going to get that 4th power. The A is going to get it, so then it's 3 times 4, which is 12. And then B is 2 times 4, which is 8. So is that first step okay there? All right. Now we're going to look at that 2 to the 4th power. So 2 to the 4th power is 2 times 2 times 2 times 2. Which again, I don't mind if you guys use your calculator if you need to. This is going to be 16, so 2 to the 4th power. If you guys don't know how to put exponents in your calculator yet, please ask. Like, you know, especially when we're working on homework, you don't feel like you have to be like, I don't get it. You know, let us know. The calculator is really easy to use once you know what button you need. And then this is a 4 still, so I have to multiply those. So 4 times 16, is that 64? Now we look at the A's. How many A's do we have? 3 and 12, so 15, right? And the B's, this is a 1 and an 8, so that'll be 9. And the last 2 questions, I like these because they make you think a little bit of problem solving, like kind of saying, if this is what we end up with, what's the missing part? So what they're trying to get you guys to do is realize, can you kind of do the opposite of this? It's almost like a little bit of algebra within this. So if I have this problem, I'm missing an exponent, but it ends up as x to the 10th, what would the little question mark be then here? Probably has like two options that you think are a possibility. Just whether or not you guess right or you know what you need to do. What would I do with the exponents here? Multiply or add, those are kind of our options. I'd be adding these exponents, so what does that question mark have to be? What would give me a 10 here? 5. So it'd have to be, a question mark would have to be 5, because it'd have to be 4, x to the 5th, x to the 5th, then I add those exponents to get a 10. This next one is kind of trying to asking us, like, what would have to be distributed in here to end up with this outcome? And you could look at all of them, or you could just look at one of them. Like if we just look at the n to the 2nd, and then to the question mark, I want that to be an n to the 6th. So you don't even have to look at all three parts. What does the question mark have to be in this case? It has to be a 3 to get that to be a 6, sorry. So a 3 there. Okay? Questions at all? So kind of try to think a little bit about what we're doing in these. So homework is listed there for you guys. Yeah, let me know if you guys are struggling with anything. If you don't know how to put something in your calculator, please let me know. Again, we only have about 2 chapters left in the year before we are at the end of the semester. We want to make sure you guys are all in a place where you're happy with your grade and that you're understanding. You're ready to move on from algebra.